Hello everyone and welcome back. Part of the workflow and the work we do is to test rigorously everything Houdini has to offer, especially when something new is released. And at Rebelway, we do this thoroughly whenever we have something new and we need to learn how to use it. Igor Zanik does a lot of the work when it comes to Houdini flip fluid and wedging and testing all of this. And we use similar workflow for Pyro and or any other solver that we want to test. What we've done is we've gone through every setting, every option this has to offer, and we tested it. We tested it at different parameters, we tested it under different conditions. This workflow is very, very solid and will allow you to quickly test things out, and it's very, very simple to use. You can go as fancy as you want with building something similar in tops or using command lines or using Python. It does not matter how complex the system is or what technique it uses. The end goal is that you are able to test and wedge things and compare results and see them in the viewport. So we have this new system, right? We have a new temperature model, we have new advection methods, we have all these controls, and we want to learn how to use it. So what we've done is we've created a small library or a large library testing every single parameter there is in the solver. Okay, and I'm going to show some of the final results. So for example, we have this is for the combustion model. I'm going to skip that. So let's say, for example, we want to test the disturbance. Okay, we want to test the disturbance under the shape, this one. Okay, we want to see how it works. It has a variety of options and we want to see how it works. So we've created files and we've created hip files, and each one of them has a different setting. And you can see here, this is the setting or the value that's been changing between these four variations. And the idea is to do one test at a time and then combine four side by side. And this will easily show you what that value is doing to the sim. Okay, and you have access to the hip file if you want to go back to. And by doing so, we can easily wedge out the turbulence settings. We understand what the scale does. We can test the combustion model. We can test everything we want. So this is a quick one to show how the system works. And you can put any setting you want here. Okay, you can test any value, and we've done, and you can add anything else you want. So for example, once we get to a more advanced setting and we want to try and create, let's see, we want to try and create, for example, we have a sim that we like, okay? And I want to try some complex cross product or some complex techniques on how it would affect the sim, on how the sim would look like. I can start creating all of that. Okay, so for example, here I have a basic sim and I'm testing a technique to add cross product force based on the sim to give it that extra rolling effect. And I can add notes here and explain what I'm trying to do in the sim, and then move on to the next one and then add some more features to it. Unfortunately, I've started, because I was running out of time, I started using the full name to express what I'm trying to do. But all of these workflows can be used to test simple settings as well as advanced techniques. Okay, so and we're going to provide the hip file for all of this. So let's take a look, for example, at the turbulence. Okay, so this is all the settings, and I'm going to put it here, always on top. And let's take a look at the turbulence setting. And this is the values. So you can see the file name is, this is the base. Okay, this is the default setting that would come with the solver. This is the base. And then I wanted to explore what the gain does. Okay, so I set it to 1, and then I set it to 0.5. And then the influence, I would reset the gain back to the default value, and then the influence, this value, the influence threshold. I want to see what that does. And then the scale, which would be somewhere. The swirl size, or no, the actual scale, I think this one. I want to see how that affects, and because it is a very important control, I can test a variety of values, 3.6, 9, 0.15, 21. I can test a variety of values and take it all the way from 0 all the way to extreme. And then the swirl size from 1 to 100, and then the turbulence frequency, I believe it would be the levels. Yeah, so 1, 2, 3. And all of this is, each test is here. And I tried to do 4 for each control so that it can put them in the same graph. If I do more, I would pick the ones that would make sense to be viewed together. So these individual tests are from each file, and then I run another process that groups, and I handpick the files that I want to put them side by side, and we have a separate file for this. So for example, the gain, I now have this file that shows me gain 0.5, gain 1, gain 0.5 here, and gain 1. Again, because I didn't have a lot of values, I just put the same file. I'm not sure, maybe it's different. Yeah, I think it's the same, just putting it side by side. So that would be one test. And then the influence, so the influence value is changing here, and you can see how that affects the sim. Okay, and then the scale, obviously this is not something, the 2, 1 at the bottom, we don't want to go there, but you can see a value between 0.6 and maybe 0.1 would work. And then the swirl size, this is actually very, very cool. So for example, you can see how awesome the swirl size here, and then the sim. So what's happening on these flickering boxes is the sim on a specific machine is running out of GPU memory. Okay, so it's not able to display all the data, but all the other workstations are able to do so. And we have a small farm, and not everything is ready for GPU rendering, because this will require maybe 2 to 4 gigabytes of memory, and I don't think that workstation had like a graphic card from 8 years old or something. So, and this is the turbulence variation. So let me check. Yeah, VLC is trying to put the list all together. So the turbulence 1, 12, and then 12 and 1. Yeah, when I only pick 2, I just duplicate the same result, and I can see them side by side like that. Cool. So this is the approach, and I have everything pretty much. So I have the turbulence, I have the disturbance, I have the shred option, and then the anticipation is very obvious what it does, so I didn't test that. But then we have the combustion model. So this is also, we've done all kinds of testing to the combustion model, and we're going to take a look at them in depth later and study and see how that affects. And by looking at this, for example, I can have a starting file, and I can just browse, say I like the turbulence of size 0.5, for example. I like the shred of 0.1. I like the disturbance of 0.2. The combustion model, I like these values. I like this temperature, this buoyancy. I can use that as the base, and that's what we've done. So because we have this library, we can then start to use it as a base. Okay, so we start with the gathering base, which I pick the settings I wanted, and that would be my base. I do a test, and then I start adding custom forces on top of that to do my own research. So all of this is built on a test where I liked all the settings, and then everything else is basically me trying all kinds of techniques and all kinds of tests to basically try all ideas I want. Okay, I have an idea about combustion, I have an idea about custom forces, I have an idea how to tweak the flame, I have an idea of anything I want. I do a hip file, I do a test and see how it looks, and I decide from there. And the goal from all of this is to give the student a deeper understanding of all these options and a base of what to use. So instead of starting lost, you don't know what this does and what that does, by simply going through these files, you will fully understand how everything works. And this system can easily be injected into other files. So if you have a different setup and you want to use that, you can definitely use it and put these nodes in, and you should be able to have the same graph and same preview. So we're going to continue studying this in the next couple of videos. Thank you guys for watching, and see you in the next one. Bye bye.